Okay, so basically, it seems that some may have some questions about actually the object-oriented part of the design. So this is 1 hour for us to raise these questions and discuss them. So if you have something in mind right now, so you can go ahead and ask.
So once you said something in the lecture, and then I asked you about it. It was that you said that each object should have at most four attributes, and it should be no longer than 10, 15, and each function should be no longer than, let's say, 10, 15 lines. But I checked lots of GitHub repositories for big packages, nothing small. And I noticed that many of them, they have this lot of, like, some big function, like the big functions was not something very common, but a class that has 10 and maybe even bigger number of attributes was common thing to find.
Yeah, that's for sure. Actually, most of the things which we discuss at the lectures concerning object orientation will be against the common practices. So once you go on public repositories, if you find some large software products, then most probably you will find there a lot of things which contradict to what I'm trying to teach you at the lectures. So looking there and making examples from there, I would recommend not to do. I think it's not gonna help you this way, because people, even if you look at my repositories which I create, my code, then still you will find things which are not what I'm trying to teach, because very often we need to implement stuff the way we can, not the way we want. And for example, this limitation. So even in my book, I'm saying the biggest number of attributes should be 4. And I can explain you why. I have like a philosophical reason. I'm saying that, in my opinion, an object is a representative of something from a real world. And by real world, we mean something which stays outside of the scope of visibility for this object. So let's say the object is a file. So the object called file. And when you instantiate this object, when you make this object, then you provide for this object the location of the file. So you say this is the string, which includes the physical location of the file in the file system. And this is your object. So your object knows about the location of the file in the file system. So the external world for this object is the file system. When you talk to the object, then the object is a representative for you of something which exists outside of the scope of visibility for this object. So let's say you create an object file, and then you say file.read. You call the method of the file.read, f.read. For example, f is the object, so f.read. When you say f.read, you mean you talk to the file and say, how about you go to the real world, which is a file system for you. Talk to the real entity in this world, which is a real physical file. Then do your thing, do what you have to do, and then return back to me something which you produced. In this conversation, the object talks to the real world. And in this real world, I believe that in order to specify what's what in this real world, there should be enough 4 coordinates, 4 dimensions, x, y, z, and maybe t as a time. So that's the philosophical idea. So the real world should not be more complex than 4 dimensions. If your real world, which your object represents, is more complex than 4 dimensions, then probably your object is not designed well. So you probably represent something too complex. So you need to break your object down into smaller objects. So for example, with the file, there's one attribute. So if you represent something with one single dimension, just the name of the file. Let's say you create an object which is a picture on a canvas. So in this case, you say, okay, it's X, Y, and maybe the color. That's 3 dimensions already. So you represent something on a flat canvas, and there's X, Y, and the color. But if you represent X, Y, the color and the temperature and the speed of movement, and also the coordinate of a user cursor or something like that, then you represent, then you probably misunderstand what is the real world for you, what's the external world for the object. So in this case, you have to break it down into two more objects and so on and so forth. That's the philosophy of that. 4 dimensions, that's enough. But sometimes you may need to have 5. And when you break this rule, this principle, then you just break it. So you don't stick to it like in always, but you keep it in mind all the time. So you just remember that the longer the list of the attributes get into your object, the more the higher the complexity, and the less properly, the less adequately you represent the external world. So you probably represent something which is too complex.
Then how do you usually represent some parameters? Let's say that they describe some object. For example, we have some object. Let's just make it a chair. And this chair has lots of attributes that are important for us to describe it. Mm-hmm. How this can be represented in the object itself?
You make smaller sub-objects. So of course you cannot represent everything with one object because the external world is too complex. You cannot just make one large object which represents everything. So you need to somehow, which is what DDD is about, domain-driven design, is about inside your scope of visibility, which is like, for example, your function or your class, something which you look at. The scope of visibility is what you look at, like your program. And there's a lot of things in the external world. And then you look at this external world and you take those pieces, for example, a chair, and then you make an object inside your program to represent that chair. And you see there are many properties, there are many things which we can say about the chair. For example, the height, the weight, the owner, the price, the color, many things. Depends on what you're talking about. For example, it's a shop. So in the shop, we sell chairs. So for each chair, we can say many things, like who ordered the chair previously, who is the owner, who is the supplier, who is the previous orders, the price changes, many things. But we shouldn't represent it with one object. We should say we know many things in the external world. The price, for example. So we have a chair and we have a price. How about we make it 2 objects? One object will be a chair, another object will be price. And then we connect them. So we say a price is an attribute of a chair in this case. But then, for example, the price has changes. So the price has a history. So we want to see, okay, now it's $2, I mean $20. And before last month, it was $25. So how do I check the history? One approach is to say, okay, the chair has a price and the chair has the history of price changes. So there are 2 attributes. One is the attribute is the price, 20. Another attribute is a collection or array of previous prices. That's one approach, which is okay if that's it. If that's all we want to know about the chair, the price and the previous prices, then 2 attributes more or less okay. But if there will be more attributes, like I said, owner, orders, whatever, then we better say, okay, we have price and price has the attribute previous prices. So we move away, we take away the history of prices from the chair and we attribute them to the price. So we always try to keep the chair with just 3-4 attributes. Everything else goes to sub-attributes. So eventually, the more complex is our object, the larger will be the tree of objects, the hierarchy of objects.
I got it. Okay, but this in this case, we will still, okay, so we will create a new class called the price. And this price would contain the price as an integer and the history of price and everything related to price. But at the end, in this shop object or chair object, we will have attribute price, which is okay, another like an object of some class price. But we will also have, let's say, capacity class, like just making this as a separate class didn't solve it.
Let me, can I just go, because I understand what you're trying to say. Okay, we are, from the point of view of you, Yegor, you're just saying that to distribute our object into 4 dimensions. Then now, after that, you create another object, right? What Fad is trying to tell you and what I'm trying actually to understand, what will be the connection between these two new objects? Right now, in terms of our chair, we have, let's say that we have a shape, this chair is shape, time of movement, you see either fixed or not, a color, a price, what else? Like we have like 5 here, okay?
Mm-hmm.
What other things that we can say? Let's make it 6, guys. Okay, so it's type, it's fixed or movement, material, color, and movement. Okay, now let's break these things up. But what I think that you're trying to, what I think your point of view is not trying to break these primitives, right? To look at it from a more philosophic way of design. So this chair is, we can represent it in many ways, but are we representing in the primitive way or object way? Like when you're saying like 4 things, is 4 attribute, is it object 4 objects or 4 primitives, or primitives and object in general, in both? You see?
Yeah, I see. You know, in object-oriented world, there should be no primitives, ideally. So this idea of primitives and objects are coming more from practical programming. Like we have them in Java and many other languages. We have primitives like data, 1, 2, 3, 4, 5. And then we have objects, which are more, complex structures with the properties and behavior. But in true object-oriented world, for example, in Ruby programming language, we don't have this stuff. We have even numbers 1, 2, 3, 4, 5. They're also objects with their properties. So you can also call a method on number 1. So you can say 1 dot something. That's Ruby, for example, programming language. So that's to answering half of your question. The other half, you're saying you have a chair, and on the chair you have different movements. You have the attributes of a price. You have properties of a price, properties of the height and weight, like a physical object. So many different aspects of one element. In this case, we need to think how to group them together. For example, you can move the chair up, down, left and right, and so on and so forth. So we can group these properties in some object, which we will call movements of chair. Or the for example, the attributes, the things which related to the price. So we can say financial aspect of a chair. That's going to be the object for us. So we group things together and we think what is the right name for this collection of things in the real world. For example, when you look at the chair, your mind also think the same way. So you think that the chair is a physical object, so it has some physical parameters, and in this case you group those parameters in some way, and you call this group as physical parameters of a chair, or somehow else.
But again, this answer is not general, because you are saying we will group the parameters, but there are sometimes set of parameters that cannot be grouped in a way that, okay, it will contain only, let's say, 4 or 5 parameters. If you will say, okay, for example, if we have a price and color, they have nothing in common except that they both are physical parameters, or like, let's say, just parameters. So we'll reach to some point where this object, even if it was sub object, it will have, for example, 6 or 7 parameters that there is no more way to break them up into 2 groups.
How this could be? Why can't you just group 6 things into 2 groups by 3 things in each group? Like what could limit you? What could be the problem?
What would be the common in between? For example, why these 3 are different from these 3? Unless we will just say, do something like the attributes that start with letter A or something like this. I mean, nothing, like, it would be less logical in that case.
Maybe we have to step back a little bit and think, what do we call an object? Because it seems that now we discuss more like a data structure instead of an object. So in data structure, we definitely may need to put things together. Let's say it's a data structure which we have in a database. So it's a database, it's a row in the table. It's a long line in the table. And in this table, you say, okay, we have columns. And in the columns, if it's, for example, a chair, then we may have 15 different columns. And each column, some attribute of a chair. But object-oriented thinking and objects are not data structures. So we shouldn't map directly a data structure to object-oriented world and say, okay, our object is just the same as we have in the database, but now we have it in memory. This is probably what the confusion is coming from. So the attributes in an object are not just the data which represent the object. They are the coordinates of something from the external world. For example, with the file, the example with the file, we have an object file, and then the object file encapsulates the location of data in the external world. It encapsulates the location. It doesn't encapsulate the data from the external world. It encapsulates the location. The same for the chair. So if you say, I want to represent the chair in my object world, then okay, this is your chair. And then the question is, where is the data? The data may stay in some memory, for example. In this case, the chair encapsulates the location of the place of a memory, for example, to some data structure or some, if depends on the language you use. If you use Java, okay, maybe it's a hash map there, or it could be an array. So something with the data. But the object itself should not be the storage of data, which usually they are. Usually objects are storages of data. We, programmers just used to have this in Java, especially in C++ as well, because we train to do it this way, but that's wrong. So the object has to just know where to find the data in the database, in the file, in memory, in hash map, in array, somewhere. But when the object starts holding data and it becomes data transfer object, then the whole object idea falls apart because it's not anymore an object, it's just a data structure. I'm not sure I managed to explain it correctly.
I think I understood it completely.
I got it. Yeah, now I understand this point.
Yeah. That's the idea, yeah.
But can I just, in order to make sure that I understood correctly, that in terms of chair, just we group the similar attribute and we create a class for them, an object for them, not a class.
Yep.
Okay. And I asked how we connect them, but what I understood that we don't connect. It's actually we just group objects, and this chair will become this chair object. Instead of have a price color, it will have like a price object, and it will have multiple, like for example, currency and the amount, and colors will be maybe the appearance, and it will have color, shape, these kind of things. And these are the four things that you're talking about, that try to group all things that can be grouped and put them inside an object no more than 4, right? That's what you're talking about. Okay,
exactly.
Okay, I got it.
That's the ideal way. But again, if it's possible to think about objects more like things which point us to the data instead of holding the data, that will help us a lot. So the less data transfer objects we have, the better. Because you understand what is data transfer object, right? It's just an envelope for different data attributes. So there's a string, number, and then you just wrap it together and say, this is my object. The object is chair. But if you look inside the chair, there's no behavior even there in most cases. So there are no methods. So it's just many attributes which represent some data. And then you just go to the object and say, give me the weight, give me the price, and all the object does, it just takes something from this data and returns back to you. There is not really encapsulation. In this case, you don't really hide the data like object orientation wants you to do. So you're supposed to do differently. You're supposed to hide the data so that we never be able to access directly the price of a chair. We're always gonna come to the chair and ask to do some manipulations. But what is the data? How they're stored? Maybe in a file, maybe in a database. It's none of our concern, and we should not even see. We shouldn't even understand how this data is in the object, how the data is organized in there.
Yeah. Can I ask like a different question? How to decide to go with this one? I always was wondering when I was teaching UML or was studying UML, or for example testing UML. Let's stay in UML, for example, UML design. It's really who creates UML? For like a developer or software engineers who doesn't code, like who is responsible to create the graph for, like for example, a sequence diagram or use case class diagram, or do we actually use them in big enterprises?
Yeah, good question. So who is making the diagrams, and more like what's for, and what's the goal, what's the purpose, and why we do this? In general, I think there's diagrams, not only UML but any diagrams. They need the people who are trying to explain something. They need the diagrams. So when I'm trying to explain you something, then if there is me and there is you, then there's a communication channel, and through this channel I'm sending some information, and this information I want to be understood. I don't just want to send it over, I want you to actually receive it and understand it. And very often the text is not easiest way to explain myself and not the easiest way for you to understand me. That's why people invented diagrams. You know, they say that it's one picture is worth 1,000 words. So the same here. So technical conversations are well better delivered in pictures and diagrams. And the UML is one of the formats to explain them. So to answer a question, who makes diagrams? Whoever wants to be understood. And why you want it to be understood, that's a separate question. It could be different scenarios. For example, you want to get money. Like, for example, right now we're working on a project, which I'm working on the project, on a white paper of the project, which is supposed to be funded by those who have the money. So in order to deliver them my ideas, I need to be understood, and I want to get the money. Of course, I can explain myself in just text, but I understand that in this case, probably they will understand less. And they will have not enough time to read the whole text, like 20 pages of my text. I want them to read it quickly in about half an hour, understand the key points, and give me the money. So I want this. I want the diagrams. It's not that they ask me for the diagrams. They don't ask me anything. They don't say, please make sure you have 5 sequence diagrams in your document. Nobody says this. They just say, whatever, you want the money, come to us, bring the document. And when I bring the document, I want them to understand me. That's why I use diagrams. That's all. And if I use UML, why I use UML? Because I want to get the money. And I know that the people on the other side of this communication channel, they respect UML. They will feel that I am much more professional if I use UML. And it will be easier for them to understand me because I use UML. That's it. So it's very selfish reason here. I just use what I use in order to get the money. That could be one reason. Another reason, for example, I don't know, you're the student, or one of you is a student, and you want your document, you want to get a good grade. So in order to get a good grade, you want your teacher to understand you faster. If you write a text of 3 pages, then most probably the teacher will have no time to read this stuff. And the teacher will give you the lower grade. That's all. So again, your selfish reason. So you use the diagram because you want your teacher to understand you faster. Again, nobody is telling you, well, in the case of a course, maybe the teacher will tell you, okay, we expect you to make 1 sequence diagram. But that's only, because we kind of trying to help you to find a way to get a higher score. But in a more strict course, in a more stressful situation, we would say, whatever you do, just bring me the project, 10 pages, explain yourself. The best project is going to win, and is going to get the highest score. And then you will just lose if there is no sequence diagrams, because I will open it up, I'll read it, I see, okay, no sequence diagram. I don't want to read the text, how this algorithm works. It's too hard for me. So I give you B or whatever, I give you C. So it's your selfish reason to make the diagram perfect so I can understand it. And there could be many other examples, scores, money, whatever. Well, I use diagrams for money. In most cases, I just want my documentation, because most of the documentation I write, technical documentation, eventually they land on the table, on the desk of somebody with money. That's why I write them. I rarely write documentation large documentation for other, for example, programmers. Well, I do. Well, when I do open source development, I do some README files. I explain how it works, but there I don't use diagrams, because my open source projects are quite small usually, and I find it easier to explain everything in just a few paragraphs of text. But when I go for money, when I do some larger projects, then I always use diagrams, because I understand that money people, they don't understand text. They don't have time to read the text. That's why diagrams.
But people with money are usually clients. Do clients understand these UML diagrams? People with no non-technical background, non-IT background.
Most of them don't. It's a good question. Most of them don't understand UML, that's for sure. But those who don't understand UML, they don't understand anything. And they just understand, are you professional? Am I professional or not? So for them, okay, it looks, oh, that's UML. That's something cool. So this guy probably knows what he's talking about. That's the impression you make. And most clients who you will meet in your life, they will have little understanding of what's going on, what is computer, how they work, what is programming. They will not understand UML, but they will see that you're professional. So don't step down to their level. That's my recommendation. Don't just think, okay, these guys are incompetent, and that's why I'm going to draw pictures and flowers and nice, PowerPoint presentations because they don't understand UML. No. In this case, you just step down to their level, and they will respect you less for this. Instead, make UML, show it to them, and they will be surprised. They will like it, and they will choose you out of many others.
Oh, good tip. Thanks.
Yeah. That's what I'm doing. Always. I know that people don't understand these diagrams. That's just obvious. But for them, it's like with the science, mathematics, like formulas. When you make a paper and you write a lot of formulas and they look, you look like smart formulas, then people respect you much more comparing to you saying the same, but in plain text.
Yeah, sure.
That's how science works. Unfortunately. The same with computers. But in case of computers, when you do UML, you do yourself a good favor because you stay with the documentation, which is pleasure to work with. I put it this way. So the documentation which is written in UML, which is written well, which is designed well, is something which you have fun to work with, which you enjoy working with. No matter what the customer is thinking, you just will have more pleasure to touch your documentation.
But I think that when you said that you write it whenever you want to be understood, this is golden. I think now it's more understandable.
Yeah, I often say the same phrase that if I don't understand you, it's your fault. So if you don't understand me, it's my fault. So, but most people don't think that way. You will finish being a student and you will get to real projects and you will see how many people, especially mature old people, who work for 10 years, 20 years with software development, most of them, they enjoy being not understood. For them, it's like a real, they respect themselves a lot if nobody understands what they're saying. So you will meet a lot of programmers who will say very complex phrases, very complex words, thinking that, enjoying the fact that you don't understand what they're talking about. I meet them every day. So you go to the meeting room, you ask them what's going on, and they start explaining what they're working on, using the words which nobody knows, only them know this work, and this is how they buy respect. They think that this is how they buy your respect, people. And so that's how they sell themselves, because they are probably scared of being fired eventually, because really they have, they probably don't know what they're doing. So in order to protect their positions, they look complex. They look very sophisticated. They look very difficult to understand. And I cannot say that I really respect that kind of behavior. So much more respectful behavior is when you explain in simple words, when you make sure that I understand you. So don't make me work hard to understand what you're saying. Make it easy for me. Make this job very, very easy for me so I can understand you immediately. And UML is one way to do it.
I think because this is a discussion, right? We are just discussing each other. Yeah, I think what you just said is very golden, especially in the don't make people respect you, not to be intimidated by you. When you start sound smart, this is like a defense mechanism for you, just to somehow to be like, oh, I know everything, like I know these high level words, but this is wrong. And actually a very good example of that, like it's out of our discussion, but doctors do that. They will rely on your ignorance to make you pay. So that's one of the philosophic way. That's why, yeah.
Exactly.
Yeah, and the programmers as well, some of the like people with knowledge, they will try to intimidate you somehow, but that's why I don't respect them as well, like these kind of people. Yeah, thank you for that. um, I have one question that uh, you know, as a freelancer, okay, not in a big enterprise, you want to start a project, but let's assume that you're like a great developer, and you want to design something very elegant, so what will be the steps starting from requirement? Yeah, let's start from requirement, Igor. Okay, and start from requirement, and let's focus on design, on coding. By a by requirement, I mean what type of requirement is, if you want to do, if we want to focus there. But what I want to really, this will be a broad question. So the first part is how to reach from requirement to our code, and when start coding, what things to start designing, how can we start with solid, for example, or what design pattern to choose, or do you understand me? Like, it's a very big question. I can actually divide it for.
Yeah, you're asking if you're the freelancer, so you in most cases on your own. So there's not a large corporation, large group with the rules. It's basically you, and there's a project in front of you, and the customer who wants to pay you $500, and then you do something for the customer, and that's it. The end of the project, probably like this. No,
actually, I mean not customer. I mean like a product for you, for yourself, or maybe you're trying to build a startup or something. So
okay.
Here we are concerned about quality. For freelancing, no, we are concerned about what he wants. Okay,
Right.
but right now we have long-term quality of the code. So that's what I mean.
Okay, so you're building your own startup that's going to be your product, so you want to do it right. So how do you start? How do you follow, right? That's the question.
Yeah.
Well, in that case, I can tell you how I do it. Because I have a number of pet projects. I call them pet projects. They're not really startups. They're not really big, but I have a number of them which are hosted, which run online, which people use. Sometimes they even pay for me for them. I start first with the product which you make as soon as possible. And I usually follow the simple rule that if the product cannot be made in less than a week, like 5 working days, then something is wrong and I need to reduce the scope. So not usually, always, all of my products I do in about 2 days. So I sit down in the morning, I spend full day on working, coding, the next day also coding, and by the end of the second day, I have something online. I have something that works and does what I was expecting it to do in a very draft form, but usually maybe up to 5 days, but then it goes like 3 days on a little bit improving, adding more features, and then it's more or less done. So 1 week, that's the first step. And I do it using most of the knowledge I have. So I don't read books for that. When I do this, I don't try to do better than I can. I just put whatever knowledge I have into the product. So just do the product, just focus on features, on functionality. It has to work. Once it starts working, then I start thinking about, usually I start thinking about, what usually happens to me is that I start extracting certain pieces out of it and making those pieces sometimes very often open source. So the product gets ugly in the beginning, and then some certain elements of the product, they start looking like something interesting. Because every time I do a new product, that just happens to me, just experience. Every time I do a new product, I invent something. Like really invent. Like, this is the new way of dealing with objects. This is the new way of designing web pages. This is the new way of exchanging data. Something new happens every time. And then this new what happens, I try to extract and make a new open source library, package, something like this. Like, for example, for Ruby, I'm writing Ruby for maybe 5 or 6 years. And I just checked. I so far made 35 Ruby gems. If you know Ruby, I mean, any language, they have these packages, right? So Java, Ruby, Go, whatever language you use, Python, they have these packages which people distribute like open source products, right? So over the course of 6 years, I made 35 products like this. I just checked 35 Ruby packages.
Like it's like a third-party library?
Like third-party libraries, yeah.
Ah,
Yeah.
cool.
Which you can use, which if you start doing your Ruby project, you can use my stuff. 35. So that means that, and how many products I made, how many Ruby products I've made over the last 6 years? Maybe, I don't know, maybe 10, maybe something like that. So I was making maybe even less. I mean, the products which are for customers, for users. So maybe even less, maybe 6 or less than 10 for sure, maybe six real products, which I made over the course of 6 years. And I made 35 open source packages. So that means that every time I was making some product, I was extracting some elements out of it and making open source stuff. So that's the next step for me, which gives me a lot of fun. And it gives me a lot of things, actually. First, it's fun. So every time you make a new open source product, it's small. You can make it really nice because these packages, they're very small. Sometimes they are like, I don't know, 100 lines of code. But you package them, you design the README file, you spam about them on the forums. So you post it on Hacker News. You say, hey, I just published a new product. You posted about it on your Telegram channel. You tweet about it. So it's like fun, instead of, just coding and coding, you're like a performance man. So you wave around, you attract attention to you. That's fun. That makes your life more interesting. Second, you learn a lot by extracting stuff out of your code. You learn a lot about design, the code design, because it's probably one of the most difficult tasks in software design is how to extract something you've done and make it stand alone. If you look at the lectures which I was giving to you, I designed the slides in LaTeX. And I designed them. You have the open source. The repository is open, so they're designed like this. And when I was designing them, I put all the configurations in one large file. So one large file for all the formatting of the slides, for everything. And now probably the last week, what I'm trying to do is I'm trying to break this down, this long file, into elements. I already extracted 2 packages out of there and published them as a packages for LaTeX users on C10. So it's the same, like for Ruby, I told you, Ruby have gems, but LaTeX, they have packages which you can publish on C10. So I already extracted 2 out of them, and that took a lot of time, actually. So writing that code was fast and much easier than now extracting that pieces. And you can check the history on the repository. You can see how I'm doing this, because I'm doing this every day. So I'm trying to extract elements from there. Why I'm doing this? What's the purpose of this? Because now I'm working on something else. Now I'm working on the new presentation, which I'm going to make at the 2 conferences next week. So I have 2 conferences next week where I will make 2 presentations. I want to use the same slides or very similar slides formatting style at these conferences. But the design will be a little bit different. So in order to use a different design, but with the same engine, I need to extract certain elements from there and reuse it in my new slides. And this work takes more time than I spend on actually making the slides. That's the true story. That's what's going on right now. And the same for programming, the same story. So you write it fast, you do the code fast. And then when you start extracting some elements, that's where the most difficult and the most interesting work starts. Because that's where you start thinking about the design. Like, how can I achieve this modularity? The thing we discussed at the lectures, modularity. The modularity means that you can actually extract one from another. And in my case, in case of these slides, it's a very complex job. Why? Because I made it wrong in the beginning. So I put everything into one file. I had no time. So that's why I did it, because I need to give you the lectures. So I had just a few days. So I put everything together in one large file. And now I'm trying to take pieces away. The same for the software. When I start developing the new product, 1 week, I put everything fast. I just need the functionality. Once the functionality works, I say, okay, how about I take this element because it looks nice. It may be interesting for other people. And how about I take it away and put it to public, make it open source. That's where I start having fun. And then after that, when I finally finish extraction, then the testing starts. The very active unit testing, because at that point, people start using my product and they start reporting bugs to me and they start complaining about my stuff. And then I look at my code and say, come on, the test coverage is very low because this and that is broken. How about I introduce more tests? And then I start writing tests, a lot of testing and fixing texting, which is also fun. Because at that point of time, you ask yourself, how can you test this stuff? And usually the answer is not obvious. Testing is, we didn't talk about that at the lectures. We will talk next week about that, about testing. So testing is something which is, in my opinion, more difficult than coding. And in my opinion, people who write tests and who know how to do tests, they have to be more respected and more well paid, more compensated than people who code. So testing is a more complex, more difficult task. And then I go into testing, and that's like a maintainability phase of the project. So first step is intensive, very aggressive development, then very aggressive extraction, modularity. They like tear apart the code and extract elements. And then you go to maintainability, and you maintain until the amount of bugs like lowers down. And then you get bored and you go to another project. So where do you, because the question was about requirements and about solid principles, and how do we fit the design practices, like all the things into this cycle?
Actually, you actually provide a better answer than my question itself,
Okay.
because what you said you're focusing on results, and this is something I miss, because this pet project, I do have this pet project, but I've never, uh, make this pet project to merge them to some kind of result. But what I learned from you right now is just, you can, even if this product didn't work, you can illustrate from it something and make it work as an element or as like a third party library that somebody else can use somehow. But you know what, I found it like strange a little bit. What is the I found that you find it as a passion for you to create these open source things, and maybe this is a passion that you do. Where is the benefit of creating these third party library? Like a benefit, I can find that you have a passion on, but for me, maybe I don't find a passion in creating third party libraries. But what would be a benefit for me to create such things? Because right now I have an idea to create a cool library, for example. So what would be the benefit on that, on my career?
Well, aside from the passion, which you don't know now because you don't have experience, once you start, you will see how much fun it is. Because I think in most fun for anybody, no matter what you do open source, you're a doctor, or you are a musician, or you are, I don't know, you're a cook, you're a chef. The most fun, the most enjoyment in your profession is coming from satisfied customers. So when the customers say, wow, that's great, we'll love it, so please do again, please come back again, we want your product more. That's what gives meaning to life, I think. When you find the customers, interested customers who really need you. So when you feel that you're needed, that's meaning of life. And open source gives you that right there. Because when you work for a boss, when you work in your company, then you have a very limited amount of people who can give you this feeling, who can give you that feedback that, you know what, we need you, we need your results. And usually these bosses, they manipulate us, and they don't give that. They will manipulate you and say that we will give you this later. So you deliver the result, maybe then next year we will tell you that we need you, but that's going to happen later. But we want it every day. I don't want to wait for a year. I want this every day. I want every day something to happen to me that I feel that tomorrow I wake up and I want to work again. How do I get it? Open source is the answer. Well, there are a number of answers. The first answer is open source. The second one is writing, publishing, blogging. So you write some ideas and you publish them. And then you get emails from people who will say, thank you very much, we love what you publish. For example, look at these lectures, which I'm reading you right now. I publish them on YouTube. Why do I do this? Read the comments on these YouTube videos. There are many positive comments, like people saying, great lectures, please continue, publish again. And that gives me energy to continue. Because otherwise I would be but I would not be very enthusiastic. I would be a little bit lazy, and I will do it just because I have to. But now I feel like an energy. I feel like, oh, great, there are people who watched my lectures. For example, these lectures, we published them, like some of them published just 3 days ago. I already have about 1,000 views on some lectures. 1,000. How many people we have in the room? I don't know, 20 sometimes, maybe up to 50. But now I have 1,000 views. So 1,000 people watch that gives me what? Well, that gives me this recording as well. We recorded right now. How many people we have here in the room? Like 7? You know how many people will watch this conversation in a week? We're gonna have like 1,000 views. So that gives a feedback to me that there's a point of working again. So open source will give even more, because this talking blah blah blah, it's good, but it's not real product. With open source, you put some stuff in there, you make your product on GitHub, you make it open source, you package it, you make it possible for programmers to use it in their code, and you will see how many people will start emailing you back and start asking you, please introduce new feature, please continue, we need your product. That will give you tons of satisfaction. That's one. Second one, which is more practical, it's money. So I believe that open source is a direct source of money for modern programmers. Why? Because when and if you have open source products, popular products, not just a product with 1-2 stars on GitHub, but popular products on GitHub, which are used as packages on your CV, on your resume, then your salary, which people will offer you, will be much higher than what they offer to other people. So your career will just boost up. I mean, look at my career. My story is exactly that. I'm not a great programmer. I'm not like, I don't know algorithms. I cannot write really complex code. As a programmer, so if you ask me to implement something very complex, many people are much better than me. Definitely, for sure. Who will write the code maybe faster than me, who will write maybe better code, but they get less money than me. The question is why? I can tell you why. Because they look like average programmers. They don't look like programmers who stand out. They look like people like everybody else. When you have your open source product, when you have something which difficult to make, an open source, a popular open source product, it is difficult to make, because in order to make it, you need to prove to the community that what you do is actually new, that it makes some sense. It's like with the academic publications. One story is that you're the researcher, you're smart, but no papers. I mean, you're nowhere at no conferences. Yes, you're smart, but who knows about that? How can you prove it? But if you have a very big publication, which is cited by other publications, that's it. You don't need to prove anything. We just pay you 2 times more. That's it. We don't check how smart you are anymore. We just trust that if your papers are cited, you're smart. That's it. So nobody gonna send you through an interview and will say, okay, please sit down, write code for me. It's never happening to me. I mean, nobody's asking me to write any code when I go to the interview. It's just not happening. Even though they expect me to be a programmer, but they don't ask me anything like this. They don't test me. They just come to the interview, and in most cases, we just discuss what the job will be about, what is the project, what are the expectations, what they're looking for. But they immediately, right from the start, they trust me. They understand. They just check my GitHub account and they say, oh, okay, we understand you made like 100 different products so far, 100. So how can we test you? Of course, you know how to write in Ruby. And of course, you understand Java because you wrote so much. The same for you. You write code every day, but you don't publish it. So you write for, I mean, not you personally, but imagine you're the programmer who doesn't go open source. So you write code, you work it for money, you make money out of this code, but you don't publish it. So after 10 years of working like this, there will be nothing. You will have to prove again that you can write code. In 10 years of work, you will come to the interview and they will tell you, okay, here's the Java code, like code this task for us. Because we don't trust you, we don't know who you are, we don't know whether you can or cannot code. But if you, being now a student, during the next 10 years, will create 5 different products, open source products every year, and in 10 years, you're going to have 50 products. And nobody will ever dare to ask you, can you code or not? So it's money reason. So you will boost your career by making open source stuff.
But the thing is that you are a content maker, you have lots of followers, and you can market your products. But as someone who has, let's say, who's not a content maker, how is it possible to market these outsource products for others to use? Not just for marketing, for even if it was a really good product, how it can reach others as an open source.
You know how many products in my GitHub account I have with that's just 0 stars, just absolutely not popular? A lot. Maybe 80% of them are not known by anybody. So it is a matter of numbers. So not all of my products, even though I'm, like you say, I have some instruments for marketing. For example, I have a Twitter account. So I can tweet about something on Twitter account and immediately people will it will be noticed by hundreds of people. But still, even though I have these instruments, most of my products, most of my libraries, packages, whatever, absolutely not popular. Nobody needs that. So it's a matter of numbers. So even if you are not known, you just make more. And eventually some of them will be recognized. I even wrote a book about blogging a few years ago. And in this book, I made an example, like how it happened to me. And a few times when I was making a product, a software open source product, and I was trying to promote it. And that was a long time ago when I had no instruments of marketing, almost nothing, because my Twitter account was empty. Nobody knew me. And I was interested to promote it. And I was posting the link to my new product on Hacker News. Hacker News is a platform where you post your stuff, and probably you know. And I posted 3 times. One time, no reaction. Another time in a few months, no reaction, absolutely zero. And then on the 3rd time, I wake up in the morning and I got 300 stars on GitHub. No logic here. You don't know why it happens. It's just, you just keep doing it. Just keep doing it. And eventually you will succeed. That's all. So there's no recipe. And not only no recipe, but even if you're very popular, there is no recipe. So my position and your position are almost the same when we're talking about open source small products. Of course, we're talking about, if, for example, we're talking about, I don't know, submitting a talk to a conference. And of course, for you, it will be more difficult because they don't know you. They're going to check your account and say, okay, who are you? We better get this guy because he's more popular. But if you make a product and submit it to Hacker News, nobody checks what account it's coming from. They only check your README file. And if the README file is interesting, if you made something interesting, they just give you the star. They give you the GitHub star. That's all. They don't check who you are. It doesn't matter. They just like the product. So the same for example, we have these channels in Telegram. We have channels for each programming language. Channels where people talk, groups, not even channels, where a few thousand people sit there. They're programmers. They talk to each other. I know the channel for Java. I know the channel for Ruby. So I write Ruby and Java. So I know these 2 groups. And they know me a little bit there. So every time I make something, I just go to this group and post there a message like, hey, I made a new package. I made a new product. How about you check it out? And I get some feedback, sometimes 0 feedback, like nobody's interested. But sometimes like, boom, I get like 30 stars, 50 stars. Mm-hmm. You can do exactly the same. Nobody's going to check who is posting here. They will only check the product.
I understand.
Yeah.
Okay, I have a question. So how do you divide usually between working and learning something new? Learning as reading, for example, or anything else, or course, I don't know, or even learning from internet, let's say.
I don't know. When I was younger, I was reading a lot of books, to be honest, like a lot of books. But then I stopped because it seems to me that I probably read everything I needed to read about software development. I read way less books right now. But 15 years ago, I was reading maybe 3-4 books every month, like a lot, like every week, like a new book. So I would recommend you do the same. At least the books I recommend you at the courses, that definitely I would suggest you to read because they are important. That's one. And after that, I also have an article about this on the blog, like how to encourage us to read and learn something. And the recommendation is always the same. That's how I do it usually, is that you give yourself a task. And then to achieve this task, you will have to learn something. And usually this task, make this task more complex than the previous task. For example, you, let's say, like in this example, like in this course. So you are now learning software design. So you have to learn it. You have a few weeks for that, a few months for that. So you have to learn it. So give yourself a task. I will design this new product, which is giving me fun, which will give me maybe money, which will give me something. But in order to design that, I decide, okay, I will do the design with UML, for example. Or I will use it, and during the design, I will use 10 design patterns. That's my objective. And in order to achieve this goal, you will have to read the books. You will have to understand UML. You will have to train yourself, but not the other way around. So I'm completely against learning for learning. Like, let's sit together and learn new programming language. That's absolutely boring, in my opinion. I would never do that. Just let's learn Go. Or for example, Rust, it's a new programming language now, and everybody like is talking now about this. And I was thinking, how about I learn it as well? But I have no task. That's my problem. So I'm waiting for an interesting task. The moment I get an interesting task, I will choose Rust as a new programming language for it. And in order to complete this task, I will have to learn Rust. But not the other way around. I will never read the book on Rust sitting on the sofa, reading and studying and studying. It's completely, I think it's very boring. So always start with the task. Give yourself a task. And actually, my blog post is about how you help kids to learn. For example, you have a kid who is 10 years old. So how would you encourage that kid to learn something? Being a parent, I would not push the kid to learning. I would only define tasks. I mean, make the objectives attractive to that kid. Let's say what happens, I would talk to the kid about what happens when you, for example, make a new mobile app. And the kid would come to me and say, but how can I make mobile app? And I would say, I don't know, maybe there are some books in the store. Maybe let's go to the store and you pick up some books about that. I don't know. But I know how great it is to make a new app. And if you make it, then this is what happens to you, A, B, C, D, E. So the kid gets motivated, and then the kid finds how to get to the goal, finds the books, the articles on the internet, install the software, everything. The kid can do it, whatever. It's not a problem. The same for students, the same for everybody. So don't tell people, I'm trying to, not to tell them what to learn, but set the objective. The same for you. If you want to talk about self-learning, set yourself a good objective. Make sense?
Yeah.
So don't learn for learning. That's boring. I mean, that maybe some teachers will tell you that you have to, but I would stay away from that. So make a goal. Like, I want to make a good application, and this application will be designed in a new language. That's it. Let's do it. That's how I learned many languages, actually.
So usually you learn while you are doing the project, or for example, you learn everything you need for the project, then you start working on it.
No, I learn only while I'm doing the project. Absolutely. Well, I can read maybe for 2 days. For example, we start a new project, and the language will be Rust, let's say. Of course, I will sit down and I will read the book on Rust maybe 2-3 days to get the idea of what's going on. Of course, I will spend a few days on reading the book, because I don't like using something when I don't understand the fundamentals. So that would also probably be a mistake. If you start jumping into something but you don't know, for example, UML, they say, okay, design UML diagrams, and you just, okay, I saw the pictures, I'll do it. No, you better step aside, read the book on UML, like 2-3 days. You will understand the fundamentals. You will understand the difference, like what's the ideas of UML, how it is designed. And then on top of that, you start making something. And then while making, you will ask yourself questions like, how can I express this idea in UML? And then you jump back to the book, you find through the book, you find the right chapter, which you missed on the first step while you were reading the fundamentals. So you find the right chapter, you say, oh, okay, now I understand. Again, you get back to the task. Again, you move forward with the task. Again, you jump back to the book. In this case, you learn more effectively, faster, and the knowledge will stay with you. You're not going to miss it.
Mm-hmm.
You're not going to lose it. Any more questions, or we can wrap it up because time is over?
When will be the next one?
We can do it next Wednesday. Well, the one Wednesday after, because the next Wednesday we're gonna have the lecture. So let's do it in 2 weeks.
Yeah, we can do it.
Okay.
Yes.
All right. Thanks for coming.
Thanks.
Thank
Will it
you.
be only for Innopolis students, or maybe?
No, maybe next time I'll
public.
invite more people. I wanted this one to try, and then next time I'll just publish on my Telegram, and you will see how many people will join.
Okay.
Cool.
I just wanted to be careful this first time.
Yeah.
Yeah. So today we had the chance for ask questions. Next time we won't have.
That's right. Okay.
Okay.
See you guys.
Thank you.
Thanks
so
for
much.
coming.
Bye bye.
Bye.